Okay. Hi, Logan, if Logan is watching. Say hi, Logan, everybody. Doesn't that sound warm and inviting? Don't you wish you were here, Logan? Either way, we did go through this Friday. 6.4, we talked about factoring again a quadratic expression and how this particular polynomial can be factored to x plus 3 times x minus 5. How this polynomial could be factored to x minus 2 times x minus 7. X and x, again, gives you the x squared. Negative 2, negative 7 gives you the 14, and the negative 9 in the middle. This over here, graph the system, find any points of the intersection. I shouldn't say find any points, but find the points of the intersection. And we wrote the system like this. If you write the system like this, what are you able to do in your calculator? RREF. Thank you. Remember when we solved systems, we would use RREF, put it in a matrix, and we would pull this matrix 3, negative. Is that negative 3? Yes. Because it's positive 3 there. If you brought it over here to the y, it'd be negative 3, 1, 1. Bring this 2 to the left, makes it positive 2, 1, 6. And if you did RREF of that matrix, it would give you the unknown x and y that satisfies that system. So that would be the solution to that system, 1, 4. All right, I'm going to turn the page. This solve by graphing, I don't really like this approach, but if you just take that and look for its roots in your calculator, let's demonstrate this. We go Control, Escape, Doc. Let's do a new file, new. Don't save. Fresh on a Monday. I'll do this with me. Play along. Let's take this polynomial equation, move everything to one side. So you'd subtract this x, you would subtract this 3, and you'd have x to the third power plus 3x squared minus x minus 3 all equals 0. If I can find that this cubic polynomial zeros, then I would know its solutions. So menu, right? Menu, where would I go? Algebra, 3 polynomial tools, 1. Find the roots of a polynomial. What is the degree of that polynomial? 3. Highest exponent is your degree. Highest exponent's 3, so it's a degree of 3. Find the real roots, and then it just asks for all your coefficients. Coefficients of your cubic, your quadratic, your linear, and your constant. So that looks like a 1, tab down, a 3, tab down, a negative 1, tab down, negative 3. And builds this function, polyroots. What's the polynomial roots of that polynomial for x? And it gives you the roots of negative 3, negative 1, and 1. If you were to put that into a graph, that would be the places where it intersected the what? The x-axis. You have up, when your degree is 3, you could have up to 3 possible real roots. You don't always have that amount, because sometimes you end up with imaginary roots, like we learned in quadratics. Good with that, Josh? Okay, I saw you looking at it a couple times. Didn't know if there was something you were noticing. Turn the page. Look at this, solving equations by factoring. There is a way right here where you can factor whenever it's a sum or a difference of cubes. This is a little formula right here. So if there is sum of cubes, that's some value that has a cube root and another value that has a cube root being added together, like this one is right here. Or if it's a value with a cube root minus a value with a cube root. So this is back, you remember when we had difference of squares? That was a special thing to factor. And a perfect square trinomial had special factoring rules. Sum and difference of cubes are other ones that have special factoring rules. So what one is this? What would this be under? Which one of these areas? This is a sum, and that there's a plus sign. Somebody tell me the cube root, we'll call this right here your A, and this your B. So label that the A and the B. What is this first term? What would you, if you wrote it as some value to the third power, what is that value to the third power? 3 something. 3, nope, right here. We're still on the 3. 3, huh? There's more than that. So 3 is cubed and something else is cubed. 3x, very good. So it's 3x cubed. So 3x takes the place of the A. And what you already say B is? That's 1. That's the only thing. 1 cubed. So all I did is recognize that both of those have a cube root. 3x to the third power gives you 27x to the third, and 1 to the third power can also give you 1. So now I've identified my A and B. So if I know my A and B, I can follow this rule. It factors, the first part the way it could factor is A plus B. So that would be 3x plus 1, A plus B. And the other factor is this, A squared minus A times B plus B squared. So what's A squared? Any guesses? Close. No. 9x squared. That times itself would be 9x squared. Everybody see that? 3x times 3x is 9x squared. All right. Minus, because the formula has a minus sign, what's A times B? Almost. 3x. And then the last part is plus B squared. Oh my Lord, why did I write a B squared in there? Plus what? What is B squared going to be? 1. Sorry, I wrote a B squared right there. 9x squared minus 3x plus 1. So there's 2 factors. Does that help me? Yeah. This one I could set equal to 0. Then I could ask myself, does that factor farther? Don't know if it does. Do y'all think we could backwards FOIL this? It's plus here, so that tells me it's got to be minus 1, minus 1. Right? Is there anything that I can use for 9 that would end up with 3 in the middle? What are your options for 9? 3 and 3. So if I put a 3 and 3 here, I would have a negative 6x. So my other option is 9 and 1, 9x and 1x. So 3x is an option. 9x, 1x is an option. Do either of those end up with negative 3x in the middle? No. Neither one of them do. Y'all agree? So this doesn't factor any farther. So what is that? What kind of polynomial is this? You're going to end up with a complex answer. Here, I'll point to it. What kind of polynomial is it? Quadratic. We had a chapter, our last chapter was about solving quadratics, and we had a lot of methods. You remember how there were a lot of methods to solve quadratics? You could factor and set those factors equal to 0. Well, this doesn't factor. You could complete the square. You could put it into your calculator, right? You could do the quadratic what? Quadratic, come on guys. The formula, there we go. You could do the quadratic. Remember the quadratic formula was the shotgun that worked every time no matter what, even though it was big and bulky. So it looks like in order for me to know the solutions to this, I would have to use the quadratic formula because it doesn't factor. That's my approach. What's that solution going to be? Can you see it? Almost. Negative 1/3. This one over here, you'd put 3x plus 1 equals 0. 3x would equal negative 1. X would equal negative 1/3. So there's one solution. Write that out. Any factor you can set equal to 0 and you'd get it. So this cubic polynomial, or this cubic binomial, does cross the x-axis at negative 1/3. I'm going to guess that this part over here gives me two non-real answers. Because look at here, it's talking about complex roots. So let's write down the quadratic formula again. We're going to do this on our calculator in a minute, but just for remembering, it's negative what? Negative b plus or minus the square root of b squared minus 4ac all over 2a. I can find these two complex roots by plugging that in. Let's do it together. What's negative b is going to give us what value right here? 3. Remember, that's a, that's b, and that is c. B is negative 3 already, so that negative sign changes the sign of b, making it positive 3, plus or minus the square root of. Here's the discriminant. Remember that number inside the radical sign is called the discriminant. B squared is going to give me the value of 9 minus 4 times a is 9, c is 1. There, look at there, we're going to have 9 minus 36. That tells me that's negative, isn't it? All over 2 times a is 18. Good with that? So then you end up with 3 plus or minus, what's 9 minus 36? Ain't that negative 25? Oh, yeah, it's negative 27. All over 18. Negative 27. 27 does not have a square root, does it? But what factor of 27 has a square root? There's more you can take out. You can take the I out. There's a factor of 27 that has a square root. 9. So we want to think of 27 as 9 times 3. So if we factor it out, you end up with 3 plus or minus. What's the square root of 9? 3. That comes out. And because it's negative, you have an I. That 3 did not have a square root, so it stays in. All over 18. That's complex because it has an imaginary part. You got your real part in the first, imaginary part after the plus or minus. Remember this stuff? Now the 3's over the 18's, that does simplify. It would be 1 plus or minus I square roots of 3 all over what? Simplify it. There's a 1 over the 3 over the 18, the 3 over the 18. It makes 1 here and a 1 here, 4, 1 over 6. So according to my calculations, this sum of cubes could be, I could use this rule to factor to get the negative 1/3 here. And then on this quadratic part, I use the quadratic formula to get 1 plus or minus I squared roots of 3 over 6. What does that look like if you were to put it into your calculator? Let me show you. All right, So let's go to menu, algebra, polytools. Complex roots. If I did just find roots, it's going to ask for real or imaginary, or complex. I guess I get there from there too, but I'm going to go menu, 3, polynomial tools, complex roots. See polyroots. So type it in, 27x to the third plus 1. What do I have to type next? What does it give us? There's our negative 1/3. That was the one real one. And then negative, or excuse me, 0.16 repeating minus 0.28 blah, 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 I. And then the same thing plus that 0.2886751 I. Where do those decimals come from? Yeah. Remember we had 1/6 and we had square root of 3 over 6. So just to prove it to ourselves, 1 divided by 6 is 1 divided by 6. That is the first part of that, like you said, right, Josh? That's where that decimal came from. Y'all good with that? And I bet if I did square root of 3 over 6, I would get point. Let's try that. Square root of 3 divided by 6. Hey, there it is. That's where those decimals came from. What does this look like on a graph? What does this cubic function look like if we graphed it? There's a particular man, we've called him. What is he? He's the disco man. This disco man is touching what one time? X-axis. My curious brain says, prove it. I want to see it. Let's look at it on a graph. 27x to the third plus 1. Let's look at it and see. There he is, discoing it up. He's doing his business. And he only touched the x-axis once. Get it? Scoot him over. There we go. Now, menu, 4, zoom in, let's zoom in. There we go. Zoomed in a little bit just so you can see where he was breaking it down. This is where he's really getting jiggy with it. That's where he's popping that hip out there to the side. Y'all ever like to do dancing to disco music? Ever done the YMCA? Oh, I can see Steven. I bet he loves the disco music at the school dances. You can tell by the smile on his face that he's broken down. If y'all had an opportunity to live in the 70s and wore bell bottoms and high heels, would y'all do that? Sequin shirts? Oh yeah, we would have a blast. Okay, you might notice this line, you can't really tell, but this line is crossing the x-axis. That was probably 1/3. Wouldn't it be? All right, finding complex roots. Remember, the degree was 3, and that gave us 1, 2, 3 answers. Those always correlate. 1 was real, 2 were not. Uh-oh. Back. All right. Factor by using a quadratic pattern. Let's see something here. Will this thing factor? I think it does. What's the only thing I could use, because my middle term is x squared, what should I use for my first? Yes, x squared times x squared. That is one way to get x to the fourth. I could have went x to the third times x to the first, but I don't want to do that because I want to see if I can end up with a 2x squared here. What do my signs have to be? Nope. What'd you say? Oh, yeah, different. I have to have some value, some positive value minus some negative value to get a negative 8. What options should I use for 8? So I've got 4 and 2. Should the 2 be positive or should the 4 be positive? Hey, it worked. That works, doesn't it? Doesn't that leave us a negative 2x squared in the middle? All right, for bonus points today, who can tell me what this second one factors to? X, positive and negative 2. Good job, Stephen. Bonus points today. What is that called? As a name. Something squares. Remember, it was from chapter 5. We discussed it just a second ago. What was it? I can't hear you. Monomial is one. It's like a one-term expression. This is perfect square trinomial is one of them. This is something of squares. Something of squares. Difference of squares. Everybody write that on there. Difference of squares is that guy. I just knew, anytime you see a minus sign with a binomial and quadratics there, hey, go, you know what? That factors. What are two roots? What are the two of this quadratic, this quartic polynomial has for sure two real roots. What are those two real roots? 2 here and negative 2 there. What about this? That's a sum of nothing. Let's set that equal to 0. X squared plus 2 equal to 0. What do you think I want to do to that? I need to get it down to x. Subtract 2. X squared equals negative 2. What do I got to do to both sides now? The only way to get x by itself is take its square root, and x would equal, what's the square root of a negative 2? Positive and negative. Does 2 have a square root? No. All right, there's one more thing I need to write down. That's right, I, because it's a negative. So this quartic polynomial had 2 real roots and 2 imaginary roots. Show me, Mr. Bush. Menu. Let's go. Oh, sorry. I'm going to declare what I had before. And I'm going to go menu, graph entry. Let's add this function right here. X to the 4th minus 2x squared. Whoops, didn't get it all. Okay, minus 2x squared minus 8. Uh-oh. I don't see it all. I don't see it all. Let's zoom out. Menu. 4. Uh-oh. Kind of saggy in the middle there, isn't it? There we go. That is a quartic. Quartic, we're talking x to the 4th power. Anytime it's an even degree, the polynomial, or excuse me, the graph goes in the same direction. The terminal ends are both going the same direction because its degree is even. We talked about that, right? This thing comes down. It could have, would have made this is a minimum. The word has slipped my brain. What word do we use for a maximum and minimum? What kind of minimum? What kind of minimum? What kind of maximum? Relative. Thank you. Thank you. A relative minimum. Then it came up to a max, and it came back down to a minimum, and then it went back up and finished. When it makes this little, this kind of look is always what you could expect from a fourth. And if it had done that, where it crossed the x, came back up, crossed the x to its max, crossed the x, and then back, you could have had 4 real solutions. Oh, you monkey poop. If that little quartic signature would have been higher. But in what we noticed, it did not. Where did it cross the x-axis? Probably at -2 and 2. -2 and 2. And you had 2 there. Let's look at it the other way. Let's go to complex polytools. Oops. You're up. Boom, I want that again. Let's go x to the 4th minus 2x squared minus 8. There they are. Notice how it puts them in order from smallest to largest. Can y'all see that all right? -2. Where does the -1.414214 come from? Hey, very good, Josh. Square root of 2. That's these, the square root of 2. I want you to recognize what decimals are. So if you're taking an ACT and you're like, hey, I know how to do complex polynomial tools in my calculator, I still remember that. The ACT question has it listed. You know, your ACT might have the question listed like that as the answer. So you're like, okay, which my decimal matches which answer? You need to make, you need to know you can find that. All right. Got it? Get it, got it. And let it go. All right. Now I want to show y'all really something cool that you can do on your paper. All right. After you have this, you want to see something cool? Here it is. That's something cool. That's dumb. Really? Stop it. Okay. You guys are a lively bunch. All right, Logan. Hope you're doing all right. That's a little bit about solving for 6-4, about solving polynomials, finding solutions. Real solutions, complex solutions. We'll stop the video right there.